There is a line drawn across the face of our planet. It is not a political border or a line visible from space in the traditional sense. It is a seam in the Earth's crust, a fracture where the planet breathes fire and shakes with terrifying power. We call this region the Ring of Fire. It is Earth's most volcanic region, a place where the ground is rarely still. Today, we are going to embark on a journey around this volatile perimeter to understand the massive forces at play, exploring the trinity of geology: plate tectonics, volcanoes, and earthquakes. From the depths of the ocean to the highest peaks, this is the story of how our world is constantly remade. To understand the scale of this phenomenon, we must step back and look at the globe as a whole. Imagine a horseshoe-shaped belt draped across the planet. This belt encircles the vast Pacific Ocean in a fiery arc, scientifically known as the Circum-Pacific Belt. It is here that the statistics become truly staggering. This single ribbon of geological activity is home to 75% of Earth's active and dormant volcanoes. Furthermore, it is the stage for 90% of the world's global earthquakes. If you are looking for the pulse of the planet, you will find it beating here, along this line. The scale of the Ring of Fire is almost difficult to comprehend from a human perspective. It is massive. This system stretches approximately 25,000 miles or 40,000 kilometers, wrapping around the Pacific Basin. It is a continuous chain that connects distant corners of the Earth. It extends from the Shaken Isles of New Zealand in the south, curving up through the island chains of Asia and Japan, arcing across the frigid waters of Alaska, and then plunging down the entire western coast of both North and South America. It is a truly global phenomenon. But why here? Why this specific shape? The answer lies beneath our feet, in the theory of plate tectonics. We often think of the ground as solid and immovable, but Earth's outer shell, the lithosphere, is actually fractured into giant plates. These plates are not stationary. They are floating on a semi-solid layer of the Earth's mantle called the asthenosphere. The Ring of Fire is not just a random collection of volcanoes. It marks the boundary lines where these massive plates constantly collide and grind together. It is the friction of these planetary puzzle pieces that lights the fire. At the heart of this system lies the engine of the chaos, the Pacific Plate. This is a central oceanic plate, vast and incredibly heavy. It is dense, and this density is the driving force behind the Ring of Fire's activity. As this massive plate moves, it is constantly grinding against the surrounding continental plates. It pushes against North America, crashes into Eurasia, and slides under the Philippine Sea Plate. This relentless motion creates a state of perpetual geological chaos, creating the perfect conditions for disaster and creation alike. To understand the violence of this region, we must distinguish between the two types of crust involved. We have the dense oceanic crust and the lighter, thicker continental crust. Beneath them lies the lithosphere and the flowing asthenosphere. When these two different worlds meet, we get what is called a convergent boundary. This is the subduction range, where two massive plates crash directly into each other with enormous force. The result of this slow-motion collision is dramatic. Towering mountains are pushed toward the sky. Deep ocean trenches are carved into the abyss, and explosive volcanic activity is triggered. Let's break down this process, known as the subduction zone process. It begins when the heavy oceanic plate meets a lighter continental plate. Because it is denser, the oceanic plate loses the battle and sinks beneath the continent, diving deep into the hot mantle. As it descends, the environment becomes hellish. Extreme heat and immense pressure begin to melt the sinking plate. This molten rock, or magma, is lighter than the surrounding rock, so it rises, earning its way through the crust to form volcanoes. It is a geological recycling process. Old rock is destroyed to create new mountains. The scars of this subduction process are visible on the ocean floor as ocean trenches. These vast canyons mark the exact location where subduction occurs. They are the deepest points on the surface of our planet. The most famous of these is the Mariana Trench. It acts as the basement of the Ring of Fire system, a place of crushing pressure and eternal darkness. These trenches are the physical evidence of the Earth swallowing its own crust, pulling the ocean floor down into the fiery depths below. But heat alone isn't enough to explain the explosive nature of these volcanoes. We need to look at the chemistry, specifically the role of water. As the subducting plates sink, they don't go down dry. They drag ocean water down with them. The heat creates a sweat where the plates release this water. This water lowers the melting point of the surrounding rock, creating pressurized magma. Think of it like a pressure cooker. This volatile, gas-rich magma builds immense pressure until it can no longer be contained. It erupts through the crust, forming volcanic arcs that run parallel to the ocean trenches. The volcanoes born from this violence are not the gentle flowing lava fields of Hawaii. These are stratovolcanoes. They are majestic, steep, cone-shaped mountains. But their beauty hides a terrifying temperament. They are characterized by highly explosive eruptions caused by thick, sticky magma that traps gas. When they blow hard. This is the most common type of volcano found in the Ring of Fire. Iconic peaks like Mount St. Helens and Mount Fuji fall into this dangerous category. As we travel up the western side of the ring, we encounter some of the most famous Asian volcanoes. In Japan, we find Mount Fuji. Currently a dormant stratovolcano, it stands as a cultural icon, symbolizing Japanese heritage and natural beauty. Further south, in the Philippines, lies Mount Pinatubo. Its 1991 eruption was so massive that the ash released actually cooled global temperatures. And in Indonesia, we remember Krakatoa. Its 1883 eruption was an event of apocalyptic scale, creating one of the loudest sounds in recorded human history, heard thousands of miles away. Crossing the ocean to the Americas, the chain continues with famous American volcanoes. In the USA, Mount St. Helens is etched into memory due to its famous 1980 eruption. It didn't just explode up. A lateral blast devastated the surrounding landscape dramatically. Moving south to Mexico, we find Popocatépetl. This is a highly active volcano that sits dangerously close to the densely populated Mexico City, posing a constant threat. And in Ecuador, the majestic Cotopaxi stands as one of the highest active volcanoes globally, towering above the Andes. Volcanoes are the visible fury of the ring, but the invisible fury is just as deadly: earthquakes. Let's look at earthquake mechanics. As these massive plates grind past or under each other, they get stuck. Stress builds between the locked plates for years, decades, or centuries. Finally, the rock snaps. This sudden release creates powerful seismic waves that shake the surface. It is a statistic that should give us pause. A staggering 81% of the world's largest earthquakes occur within this specific zone. History provides us with stark reminders of this power. Consider the 1964 Alaskan earthquake. It was a magnitude 9.2 event centered in Prince William Sound. To this day, it remains the second largest earthquake ever recorded in human history. It twisted rail lines like spaghetti and raised entire sections of the coastline. This event definitively proved the immense power of subduction zone tectonic forces, showing us that the solid ground we stand on is anything but permanent. When the Earth moves underwater, the danger spreads across the ocean in the form of tsunami generation. These are giant ocean waves created by underwater earthquakes or volcanic eruptions, displacing massive amounts of water. Unlike normal wind waves, These move with the speed of a jetliner in deep water. They represent a major threat to coastal communities around the entire Pacific Rim, necessitating complex warning systems to protect millions of people living at the water's edge. Not all danger in the ring comes from head-on collisions. In some places, we find transform boundaries. Here, the plates slide horizontally past each other without subduction. The most famous example is the San Andreas Fault in California. The result here is different. You get frequent earthquakes from the grinding friction of the rocks snagging on each other. But typically, there is no volcanic activity. It is a dry, shaking landscape, distinct from the magma-fueled arcs elsewhere. The violence of the Ring of Fire creates as much as it destroys. It is responsible for mountain building, or orogeny. The plate collisions do not just melt rock, they crumple Earth's crust upward, forming towering mountain ranges. Look at the Andes Mountains in South America. They are the world's longest continental range, created entirely by this process. Every jagged peak you see is a monument to the slow, irresistible force of the plates beneath them. This brings us to a difficult question. What is it like living in the Ring of Fire? It is a paradox of risk and reward. On one hand, there are immense benefits. The volcanoes break down into rich volcanic soil, perfect for agriculture. The heat provides geothermal energy, and the landscapes create incredible tourism opportunities. But the risks are ever present. Residents face property destruction and the tragic loss of life from sudden earthquakes and eruptions. It is a life lived on the edge. Yet, human ingenuity has found ways to harness this danger. We are tapping into geothermal energy, Earth's internal heat, so close to the surface in these regions, generates renewable electricity in countries like New Zealand and Iceland. By drilling down, we use the steam to turn turbines. It is a sustainable power source driven directly by Ring of Fire tectonic activity. In a way, the very forces that threaten to destroy civilization are also helping to power it. As we conclude our journey, we can summarize the Ring of Fire not just as a zone of danger, but as a zone of life. Its boundaries track the Pacific Plate edges. It is powered by the relentless motion of subduction zones. It is a cycle where destruction births new land. The Ring of Fire is the Earth's workshop, a place where the planet is still under construction, reminding us that we live on a dynamic, living world.